There we are. Hi boys and girls, it's me Butch. My name is David Silvercloud. I'm not native, just sounds that way. I'm 80 years old. I was born October 24th, 1944. And today is 17th. Jeez, I've forgotten. I can tell you if you want to know. Let's find out. Today is the 27th of February, 2025, and it's 8:30 in the evening here in Vancouver. So I'm testing out night lighting and just different things I can do with my camera. I'm an artist. What I want to teach you about tonight is what is a quantum leap. I'm sure if you speak English, you've heard the term quantum leap before. I'm sure you've heard the term before. And in your mind, I'm willing to bet dollars to donuts that you think, I'm going to try and balance on one leg here. I have sores from my hormone problems. I'll talk about that later. Hope they're gone this summer. I have such a big ego and I'm so vain. Anyhow, I'm willing to bet dollars to donuts that when you were taught about what is a quantum leap, you think it's like really big. Butch is into physics. Physics is a study of energy, matter, and motion. And it's a branch of science. Science comes from Latin words which mean to know or knowing. So physics is a branch of science studying energy, matter, and motion. And in the branch of physics, there is a branch called quantum physics. And I'm pretty sure you've heard of that one too. And you say, I don't know what that is, but it's for the geeks and the nerds. Okay, well here's a geek. Here's a nerd, and he's going to teach you that it's really simple. Well, at least to us it is. And I think you'll find it simple too. In your world, if you're not into physics or science, you have ways of measuring things, like with pounds and miles per hour, and just all things you've heard of, calories, watts. Somewhere along the line you've heard of all these things. Well, in the world of quantum physics, the basic unit of measurement is the quantum. And the quantum allows for things that can't be allowed for in anything else we know of. So it had to be invented, and it has been. So quantum physics allows for spin, either left or right. And everything really, even if you don't think it has a left or a right spin. Even me right now, I'm attached to the Earth spin. So whatever spin I have, because my feet are on the ground, the spin I have is the spin of the Earth, and whether it's right or left, I have to stop and think about that, and that gets into relativity, and I don't want to go down that path because most of you are not into science. You came here to look at me and say, who is this old geek? Who is this guy? I mean, who is he? I'm trying not to show my broken tooth. I'm waiting for the insurance to give me a new crown that I broke. It looks really ugly, and I'm really vain. So a quantum allows for spin either left or right in the quantum physics world. And what is it based upon? It's based upon another thing which I'm sure most of you have heard of. It's called an electron. Electrons give us electricity. When an electron moves, that is electricity. The motion from one atom, if this electron is tied to that atom and it wants to get away and go to have an affair with another atom down the block or whatever, that is electricity. And to get it to move will require a minimum of 1 electron volt. And that's the amount of energy this thing would have if it was just sitting there doing nothing. But because it's spinning and it doesn't really ever stop, it could. They don't, but it could. Theoretically, it could. It would still have its one quantum of energy, except it would have zero spin. Get the drift? So in quantum computing, they want to compute zero. They'll say when it's fully spinning, it's on. When it's not spinning, it's off. That's one way of switching the switches off. And in a computer, they're using so little electricity, they are basically using one electron at a time. It's that small. And using one electron volt to move the electron from one thing to another. So, getting back to the definition of the electron here, I told you how to spin. When this wayward electron decides it wants to have an affair with another atom down the block, it needs some energy to do it, and the energy it needs to get is it has to spin at least twice as fast. And when it starts spinning faster like that, it starts needing. It's spinning, but it's doing this, so it needs more room. And the neighbor down the block that it wants to get to, if it's within a bigger atom, is simply the next level upstairs. So I'm going to switch over something on the computer to try and show you something. I hope if this works. I put my glasses on, I can't see anything. She's an artist, you can't see anything. Alright, which one do I want here? I want this one, and I want this one. So, what you're going to see here, I can't point to it, but on the right side, lower right side of your screen, I'm picture in picture, so I can't really make it happen that well. I'll have to figure out how I can do that. I thought I could. Anyhow, you'll see what looks like to you your typical atom, and with the with the rings around them. And this, I think, is gallium or gallium. It doesn't matter what kind it is. It's an atom with a whole bunch of kids, a whole bunch of electrons. And every electron in those rings would like to have an opposite spinning electron with whom it is forever entangled. Throughout, as best we can tell, throughout all of eternity, once two electrons become entangled, no matter what happens to them, no matter where they go, somehow, and we have no idea how, they're always in touch with each other. They're twins, except one spins right and the other spins left. And that way, if they get together, imagine these were the same size, they could save energy because together, depending on how you look at it, they're both spinning the same way. They're each spinning the way they want to spin, because the north and south poles will be joined up, and they think they're doing fine, and they save energy. But I'm going down. I'm trying to teach you more physics. I should take off my glasses. Where were I? So when this, if you see on those rings there in the center, if this was a hydrogen atom, it would have. Let me go over here. I forget which screen I'm supposed to be on, which camera. I know what camera I'm on, I think which screen I'm on. So if this electron wants to move outwards to a higher level, it needs more room, it needs more energy, and the energy it requires to make that quantum leap. That's what a quantum leap is, dears. That tiny, teensy, weensy little distance within an atom, a single atom, between the levels of where one electron is shaken away and the next one is shaken away. We call those orbitals. And if it doesn't have a mate on the other side, then the orbital will be a donut. It'll just go around like crazy in circles. So with a hydrogen atom, you may assume that Most of the time it'll be in one place, but it could be here. They arrange themselves differently depending on how many other electrons are trying to share the space. What I'm trying to get across to you and what this video is about was to tell you that a quantum leap is, I'm going to change cameras because you don't need that picture anymore, do you? I have to look down at my computer to do this. Let's see if this works. I think it's going to work. I hope there's music playing. Well, there is, and I have 1 minute and 13 seconds left before my soundtrack runs out. So I'm going to try and wrap this up by the end of the soundtrack. So I'm 80 years old. I have serious health issues, kids, but the way I get to be the way I am, it's just my whole life. I exercise, and I try to watch my diet. I got a bit of a gut. I got that about 10 years ago and I developed hormone problems. So I want to remind all you older dudes over 40, have your hormones checked. They don't do that. And I know I come up to the end of the video because I want to make it sort of end on the end of the soundtrack. I'm going to switch things off here, and I'm going to say bye. So bye from Butch.